Today we are going to discuss about the Kotlin Coroutines. So I have some of you guys related to the Android team have the little bit idea about the coroutines. So basically, coroutines was introduced uh, to the Kotlin with the stable version when we were on 1.3 version we were using. So at that time, coroutines was introduced in the technology. So basically, it is a structured design pattern we use to make the background or the network calls to make that easy. So it was introduced in 1.3, and who invented this coroutines? It was invented by the Oliver. So you can easily recognize that name that is on the screen, Oliver. So after that, when should I use the coroutine? So basically, coroutine. I hope you all are aware of the multi-threading. And suppose we are working two, three. Currently, we are working with the two, three tasks simultaneously on our PC. Like we are using our Windows Studio or the multiple processes. We are using this simultaneously. So how they are managed by the OS? So that is the thing. So the same concept is also in our the coding when we are developing an Android application or whenever we are using the our developing our website or certain things. So we have some background processes to make them easy when we are hitting an API and requesting some kind of stuff from the server. So to make that easy for the users. That's why coroutines was introduced in the Kotlin. Earlier we were using like HTTP requests. That was some basic kind of structure. We had to. Oh, there were very much boilerplate code there. We have to write so many lines to perform that. So to overcome that kind of thing, and we were also using the RX Java. So now coroutine is introduced by the Kotlin, and that is in the use for the long running tasks, for the long running processes that we cannot use on our main thread. So that's why coroutine was introduced. So basically, that is the thing why we use the coroutines at the first place. So they provide a right asynchronous code in a sequential manner that I told earlier. Like it provides synchronous code in a sequential manner to make our development easy, so that we can write our code in. Today, we by using the coroutine, we can hit an API and get the response in the 2 3 lines only. But earlier we have to write like 5 6 line 9 10 lines for that. So that's why we use the coroutines to make that easy. So in the similar way of the thread, but that are not much like efficient way to implement the threads and to control that threads. There were also chances of the memory leakage while we are using the threads because they are uh, difficult to handle while we are developing our application. So we can overcome that problems with the use of the coroutines. So let's consider OS and the cooperating multitasking. So actually, it was used. Coroutines was in used first from the 1958 for the assembly language, and it was used for the Python, JavaScript, and C sharp earlier, and later it was introduced in the Kotlin. So we are using it in the Android. So like our OS is handling multiple tasks simultaneously. So to simultaneously perform multiple tasks, we are using the coroutines. And these are the some major use of the coroutines. A coroutine can be introduced as a sequential of the well-managed subtask. So it is not a when we have created one coroutine. So it is not a thread. It we can also take it as a sub part of the thread. We can make different part of the thread, and we can perform the different functionalities by using a single thread. So to some extent, coroutine also considered as lightweight thread because we are like dividing it into a different parts. It is not like such kind of bulky task. By using Coroutine, we are dividing our a single thread into the different subtasks. So it is a lightweight thread. So we can execute many coroutines in a single thread. As I tell earlier, we can execute many coroutines in a single thread. Coroutine can be switched between other threads. So why this? Because suppose we are using a mobile application and we have to perform a we have to perform a network request, and after that we have to update a UI. And when we have to update a UI, so we cannot rely on the background thread, input output thread. So we have to switch our thread. So to make that process, it is very easy to perform that in the coroutine. So we can switch our thread. Suppose we have hit an API, we get the response, and then to use that response, we have to update our text view. So to update our text view, what we can do, we can switch our thread easily with the coroutines uh, to update our UI. If we are not switching our thread, then definitely we will get some kind of error because we cannot update our the UI things while in the background threads. In the background threads, we cannot update our front end UI. So we can resume a coroutine from one thread and depose it from the other thread. Similarly, if we are performing a task, so and we have to pause it for some time and continue the other one. So we can switch the thread or pause it from the other thread also. It will allow us to write asynchronous code in a sequential manner. Manner is like we have to follow some kind of set in a single line. We can perform the network request for the background request. We can perform it easily. It avoids unnecessary boilerplate code which comes with callback. So suppose we are using the RX Java. So when we start a thread, like we have to hit an API or some kind of background network call, uh, we have to implement the on error method also callback and on success also. So there are a number of different methods we have to implement. So to reduce that, we have the coroutines here. So this is the thing. Why asynchronous programming is important. Suppose we are using a mobile device and its refresh rate is 11 seconds. So what is there? We have to complete our task in the 11 seconds. We are performing any task. We have to complete it in 11 seconds. If it not get completed, definitely we will get some error like ANR not responding kind of error or some UI hang there. So to handle that things, we have to use the asynchronous approach that we can efficiently handle with the use of the coroutines. So now come with the implementation. So these are the two dependencies which we have to add if you want to use the coroutines. So these are the two dependencies. We have to add it in the build.gradle in the folder. So after that, so how we can create a first coroutine? So as you can see on my screen, coroutine scope. I will explain you everything. What is coroutine scope? What is dispatcher.io? What is launch? Okay. So this is the basic syntax. This way we can create a first coroutine. Coroutine scope, dispatcher, and then launch. So coroutine scope is an interface is used to provide scope to our coroutine. So it is used to provide the scope or the reference of our the coroutines. So we have another scope also like the global scope. So global scope we rarely use it in the our application development. because whenever we have the situation, there is a task we have to run throughout the application when user is using. Every time it should run in the background, like we are performing something regularly, some kind of interval, while using other stuff of the application. In that case, we use the global scope, but mainly we use the coroutine scope only. So this is the interface, and what is the dispatcher? So this is the dispatcher.io. We can directly use IO only. In the place of dispatcher.io, we can also use the IO only. So basically, this is the context. This is the context that we pass to the coroutine scope. This is the context. Dispatcher.io. There are different kind of dispatchers: IO, main, and default, that we will study further. And so, dispatcher defined kind of the thread should be run. Our When we start a thread, it should be a main thread. It should run on the main thread. It should run on the background. So that's why dispatcher we use. We mainly define it in with the scope. We can also add the explicit job with the dispatcher of the coroutine. So what is the explicit job? Explicit job is the thing that we can add with the dispatcher. Uh, Suppose here is the dispatcher. We can define a new job and we can add plus job there to where it can be used. Job, we can suppose we have to uh, finish our coroutine at after some whenever we are finishing our activity or we finishing our screen, and if it is required to finish that coroutine, then we can finish it by the job dot cancel. So there we can use the job. So job will be defined with the dispatcher. So it is recommended to start the coroutine on the main thread, then switches to the background thread. So dispatcher we have different types. Dispatcher.main. So coroutine will run on the main UI thread if we use the main thread. Suppose we have to update a UI, then we have to use the dispatcher.main, and some kind of a network request we have, then we have to use the dispatcher.io. Coroutine will run on the background thread, and dispatcher.default we have for the CPU intensive tasks such as sorting of the list. It is related to the CPU, and dispatcher.unconfined. It is used with the global scope that we learned earlier, and it runs on the current thread. It is suspended or resumed. It will run on the suspending function thread. It is not recommended to use in the Android development. And also the default one we use very rarely. So basically, we there are dispatcher.main and dispatcher.io that are in the use while developing our application. So what is the launch? This one launch. So we have what is the launch? So launch basically is the builder of the coroutine. By using this, we can start our coroutine. It is the extension function used to launch a new coroutine. There are four type of the coroutine builders that we can use: launch, async, produce, and the run blocking. And the launch is a new coroutine without blocking the current thread. Async, we need to invoke await, and it is used when we have to get a result. Like suppose with the launch, after suppose we have written this coroutine and we have used this launch. Suppose we have to hit perform a task where we do not need any end result. We have a function that is no return type there, and we are not we have to perform some calculations in the background, some heavy calculation in the background, and after that we will get a result only, and we will so in that case we have to use the launch. And suppose we have a condition in which we have to get some result. We have to perform a network request and we have to get that output in the return and use it further. Then in that case, we can use the async in the place of the launch. So basically, these are the two builders that we use frequently in the our application. And for the await, we need to invoke await. This await we will learn further. What is this await? So suppose we are doing a background task. We are doing some kind of a calculations, and after that we have to update a UI. Like we have to print a toast, or we have to update a text. In that case, what we can do if uh, our dispatcher is IO and we are setting our text view here, definitely we will get an error. So to resolve that, what we can do, we can use the with context. With context is used to perform the UI related stuff. So you use suspend with the method because with the with context is a suspending function. Alright, we have the different kind of suspending function. So async is also a suspending function, and we will learn about the suspending function further. So with context is a suspending function. If we are using any coroutine suspend function, then we have to add a modifier suspend with our function name. So these are the suspending functions. With context is a suspending function with timeout or null, join, delay, await, supervisor scope or the coroutine scope. What we will use mainly, we will use the with context coroutine scope. This will be heavily used in the coroutine, and await is also used. Join delay, we can use this according to our need. Suppose we have to perform anything after some delay of the 2 second, 5 second, then we can use the delay. Suspending function. Probably we have used the room and the retrofit sometimes in our application. So they are also using these suspending functions. Room and retrofit also provide suspending function to help us in the development. Like behind the scene, we are only implementing our dependencies of the room or the retrofit. Behind the scene, we also have the some suspending function to make the development easy. We want to call any suspend function of coroutine API, then we have to add a suspend modifier with our function. So it is important to add the suspend modifier with our function. Otherwise, Studio will throw error. So you have to add it. This is necessary. So here is an example how suspending function works. Suppose I have a function. My function is the name of that function. We have some kind of code block here, block 1, then block 2, block 3, and the block 4. So this is a long running operation, that is block 2. So what will happen in that case? Code 1 will execute, 2 will start, and 3 and 4 will execute. But this is not finished. Block 2 is not finished. So there will be some kind of issues created. Sometimes there will be a chance we are calculating uh, so much calculations that will take 5 or 10 minutes. So what will happen, one will execute, one will done, and the two will be in continuity, 3 and 4 will complete it. So to so there will be a chance of some kind of issue we get if our calculation 2 will depend upon 3. In the 3 we need some kind of data uh, from the 2. So in that case we will definitely get some kind of error. So how to overcome that? First we have to use the suspend keyword with the that function suspend, then space, then my function. So this function will be suspend function, and after using the suspend modifier, what will happen? Code block 1 will execute, code 2 will execute, and it will wait. Block 3 will wait. Here there will be a wait until block 2 will get completed. So, and after that block 3, then block 4. So basically by using this span, our method will wait for completing until block 2 is completed. So this happen when we use the suspend keyword. So this is the functionality of the suspend function. So we have one more example to explain the parallel decomposition. Parallel decomposition is the major benefit of the coroutines. So there is a sequential decomposition and there is a parallel decomposition. In the parallel, suppose we have a condition where we are getting get stock is a function we are and it is taking 10 seconds to for the implementation, and we have the second block of code that is executed that is taking time of execution 12 seconds. So this will take get stock will take 10 seconds and get stock 2 will take 12 seconds, and after that what we are doing the calculations. So in this case, if we write this in our the Android Studio, what will happen? First, it will take 10 seconds. After that, it will take 12 seconds. So total of 22 seconds it will take to print the total, right? So what is parallel decomposition? What parallel decomposition does here? Uh, by the using of the async keyword, by using of the async suspend function, uh, here and here also, this will be parallelly executed. Like it will take 10 seconds, it will take 12 seconds, and total of the uh, 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 and we have to use this await, then we will get the result in the total of the 12 second only. Here we will when we were implementing this, we were getting result in the 22 seconds, and here by using the parallel decomposition, we are getting the result in the 12-second only. So why this is happening? This is happening because of the async. When we use the async, our whole execution will done simultaneously. We have used this async, this will done independently. This will take 10 seconds and this block will take 12 seconds. These are running simultaneously. So that's why we are getting our result in the 12 seconds only. And here is the total. We have to use the await with that. This will wait for the result. This will wait for the result. Once we get the result, it will be we will get our total. So this is the parallel decomposition. This is the sequential decomposition. So basically, we are saving our time in this. So what is the next? Next is the structured and the unstructured concurrency. So suppose we have a block of code here, coroutine scope. This is the suspending function, and this is the coroutine scope interface. When we use this coroutine scope with the capital C coroutine scope input output. Basically, this will run in the background. And suppose we have a one more coroutine inside this block. What will happen? It will not take care of the child coroutine is completed its task or not. It will take care of the parent execution is completed. It will print the result whatever it is. So there are lots of chances to get the wrong result. Suppose we have one more block of code in this coroutine scope, and we have one more block of the calculation. We are doing some total of the numbers, and it will not take and we are returning that value to the here there will be a variable. So what will happen in that case? There will be a chance the parent coroutine will finish first its completion, and child coroutine is in progress. So there will be a chance of getting the wrong result. So what by using the this small coroutine scope, we can remove that the concurrency. So if we use the small coroutine scope, this will take care of the each and every coroutine is successfully completed its task or not. So this will take care about the everything that is inside this block. So if we use the capital coroutine scope, this is the unstructured concurrency. If we use the small coroutine scope, this is the structured concurrency. It will taken care of the each and every coroutine child coroutine is completed or not. After that, we will get the mm, final result. So this was the overview of the coroutines, benefits of the coroutines, and further we have the also view model coroutine. We have the life cycle of the coroutines. So because the short of the time we have uh, completed the overview of the coroutines.